Okay, so we are talking about the opposite of a number on this slide. So that's a lot of opposites. Let's listen to what it says.
The opposite of a number. In the lesson activity, you mark the opposite of 1 and 5/8 on the number line. The opposite of a number is the same number on the opposite side of 0 from the given number. So on the number line, you mark the position of the opposite of 1 and 5/8 as -1 and 5/8. Now let's see what happens if we try marking the opposite of a given number. Look at the example in the image, which shows that the opposite of -1 is 1. The opposite of -1, the opposite of -1, is -1, which is the number we started with. If we flip a number across 0 twice, it comes back to the same place. So, the opposite of a given number is the original number.
I recognize that that's quite confusing, right? There's a lot of opposites there. But basically, if we have a 1 and we want to find the opposite of 1, that's flipping it across that 0. Remember, I told you that an opposite is equal distance, but on the opposite side of 0. So the opposite of 1 is -1. And if I want to find the opposite of that, I'm flipping it back over 0, and you're actually back where you started again. Does that make sense? So the opposite of the opposite kind of undoes what you did. So see how this looks? So this is the opposite. This is -1. This is saying the opposite of -1 is 1. And the opposite of that is going to be -1. Okay? So basically, every time you see that opposite sign, you're kind of flipping it back over. Raise your hand if you are confused or you have any questions right now. Okay, so even though it has a lot of opposites, we're understanding that right now? Okay. So let's go ahead and look at the next slide. Oh, wait, did we fill in? Let's fill in first.
Applications of number lines. Thermometers. Number lines are used in measuring instruments such as rulers, thermometers, and barometers. Let's look more closely at number lines and thermometers. You know that thermometers are used to measure temperatures in degrees Celsius or Fahrenheit. To read a thermometer, we observe where the top of the liquid is on the scale. The scale on the thermometer forms a vertical number line. On the thermometers shown here, the numbers are -40, -30, -20, -10, 0, 10, 20, 30, 40, and 50. These numbers represent a range of temperatures. The tiny unnumbered marks represent the numbers between the printed numbers. For example, the 9 marks between 30 and 40 represent 31, 32, 33, and so on to 39. Let's read the left thermometer in the image. The top of the liquid is beside the 5th mark between -10 degrees Celsius and -20 degrees Celsius. So, counting the marks down from -10 degrees Celsius toward -20 degrees Celsius, the temperature measured on the thermometer is -15 degrees Celsius. In the thermometer on the right, the top of the liquid is at the 4th mark between 20 degrees Celsius and 30 degrees Celsius. So, counting upward from 20 degrees Celsius toward 30 degrees Celsius, the temperature measured on that thermometer is 24 degrees Celsius.
Okay, so basically what they're saying is when we look at this thermometer, it's not going to give us every single number. It would be too crowded. You wouldn't be able to tell even what this is saying. So what it's giving us is it's kind of by tens. Do you see that? And then the little marks in the middle are going to be tenths, or ones actually. So I have this right here is between the -10 and the -20, right at that 5th mark. And so we know that that's going to be -15. Okay, so right here would be -15. So you would count those marks down. Right here, same thing, only this time it's a 4 up from 20, between 20 and 30, so we know that's going to be 24 degrees, okay? Is there anybody confused about how to read a thermometer when we don't have every single number marked? That's really what it's talking about, okay? All right, so go ahead and take a minute to fill in your guided notes in that section for about thermometers, please. Yeah. And we're going to go to slide 13. And this is asking, Jamie, who's recovering from a cold, checks his body temperature. The image shows the temperature reading on the thermometer. What is Jamie's body temperature? So looking at the thermometer, what do we see Jamie's body temperature as? Go ahead and mark that in on your own if you haven't already. And Nigel, go ahead and tell me what it is.
36.6.
36.6. And we are correct. Very good. All right, let's look at 14. This is another application of number lines, and this is called the account balance line.
Applications of number lines. Account balance line. Number lines can help us understand money transactions. Think of the number 0 on the number line as a condition in which you have no money, as shown in image 1. If your mother gives you $10 for the week, you can represent your new financial condition by a shift of 10 units up to the position in image 2. Now imagine that you go shopping with your friend and find a pair of shoes on sale for $15. You only have $10. So you borrow $5 from your friend to buy the shoes. You spent all the money that your mother gave you, $10, and you also owe your friend $5. As shown in image 3, you can represent this condition by the number -5 on the number line. Note that -5 is the number you get if you shift 15 units, the dollars you spent, down from 10. When money is credited or added to your account, the amount of money increases. An upward shift on the number line represents an increase in the amount of money you have. When money is debited or subtracted from your account, such as when you withdraw cash to spend, your account balance shifts downward on the number line.
All right, so let's look at these number lines. Make this a little bit smaller here. And we can see that we started out at 0. We got some money. We went up to 10. And then we spent more than we had, right? So now we're in that negative situation. So those account balances can show on the number line. So go ahead and fill in what you need to fill in on your CAMI notes. If you
Applications of number lines. Rulers. Think about a tape measure. The marks on a tape measure are similar to those on a number line. Let's look at an example. To measure the length of a workbench, we can place the 0 centimeter mark of the tape measure at one edge of the bench and extend the tape measure to the other end of the bench. Just as we would read a point on a number line, we can read the number on the tape measure exactly where the workbench ends to find the length of the workbench. We can also read a number anywhere along the tape measure to find the distance between the edge of the workbench, 0 centimeters, and that point.
All right, go ahead and fill in. Does anybody have any questions about tape measures? I think that's pretty self-explanatory. Raise your hand if you've ever measured something. Okay, I should see more hands. Jonathan, you've never measured anything?